Hi and welcome to this video about writing an icon handler shell extension. What are shell extensions anyway? So we're probably familiar with the Windows shell, which we think perhaps is just this thing called Windows Explorer, which is now has been renamed to File Explorer. But anyway, it's not just about Explorer. Explorer is really just a wrapper around lots of functionality provided by more fundamental DLLs. And one of these things is the ability to extend and customize Explorer or anything other than Explorer that uses the same interface, the same kind of functionality. And the main way to do that, the more powerful way of doing that, is by declaring and implementing shell extensions. Shell extension examples include context menu handlers, icon handlers, property sheet handlers, drag and drop handlers, file viewers, copy hooks, and full-blown objects which are part of the shell namespace. For example, if you just open up something like this PC or my computer or something like that, you see these things like these drives here. And sometimes you can also look at something called a network here. So what is this network thing? It's not really a drive, it's not really a file in the file system. You can see here some printers. These are definitely not files in the file system, which means that the Explorer hierarchy, or the shell hierarchy to be more precise, is much more complex and flexible than just being something very simple like files and folders. So we can customize these things in many interesting ways. And I want to show you one such way in this video, which is going to be an icon handler. All shell extensions are really COM objects, and we talked about COM a little bit in other videos. And I'm going to use, obviously, I would have to implement COM objects, or at least one kind of COM class, so we can implement our icon handler. I'm going to use a library called the Active Template Library, or ATL. This is a well-known library that can be used to help us write COM components to take care of all the boilerplate of writing COM stuff, such as implementing the INO interface, class factories, registration, and things like that. And so if you're interested in more information about ATL, please look at my course on TrainSec called COM Programming with C++. We'll get the very basic stuff here that's going to be enough to show how to write a shell extension, specifically an icon handler. Okay, let's get to it. So what are icon handlers? Normally when we look at icons for file extensions, we know that most file extensions have a single icon type. For example, if I look at DLL files, then I'll find that DLL files have the same kind of icons. Here's an example of an icon which exists on this virtual machine, this Windows 11 virtual machine. I've changed the view here to show medium icons. You can see all DLLs have the same icon. This is the default kind of behavior, and we can definitely change the default icon fairly easily by tweaking some information in the registry. But if you want to do something more profound, for example, change the icon of DLL files based on some real property of the file. For example, suppose we're interested in whether the file is a 32-bit P image or a 64-bit P image, then there's no declarative way of doing that. You have to write some code. That's because normally you have one icon you can specify for a particular kind of file extension. So we'd like to change that so that DLLs will have different icons based on whether they're 32 or 64-bit PEs. Let's look at something like that, which is not too difficult to implement in a video. So the first thing I'm going to do is to create a new project. And since I'm interested here in using ATL, I'm going to create an ATL project to get some of the boilerplate created for me without me having to work very hard. Again, I won't be able to explain every little detail, but we'll explain enough to make it, well, usable. So let's call that something like icon handler, or DLL icon handler, or something like that. Let's put that in my YouTube folder there. And the name of the solution is fine. Let's create the project. And we get a little wizard here for ATL to indicate what kind of project we'd like to create, but that would be a DLL, an executable. Now these kinds of extensions needs to be a DLL, so I'm going to select DLL. I'm also going to check this button here to say allow merging of proxy stub code. This doesn't have any effect on what we're going to write, because we're not going to use any custom interfaces, just existing interfaces already implemented by, defined by Windows and looked up by Explorer, which we need to implement. But it will save us from getting some extra proxy stub project, which we just don't need. I'm just going to click OK here to generate the initial project. At this point, we're going to get some boilerplate stuff like the DLL main function and other details which are not really important for the purpose of this video. And now that we have that, we can start working by creating a COM class. So I'm going to go to the project, right click, and add a new item. With new item, we'll be able, of course, sometimes we get a little annoying bugs from Visual Studio. We get the ATL part here, which we find something called ATL simple object, which is just another kind of wizard to get us up and running quickly. So let's call that icon handler, or we can call it something else like a bitness icon handler, or whatever name we want. That's going to form the base name for the class we're going to get, the interface we're going to implement. Well, technically not going to implement that interface, but it's always going to be created here. So we have some names here generated by the wizard. I'm going to stick with them, go to next, and then the next part is useful for other kinds of shell extensions like a preview handler and things like that, which we're not going to implement here. So I'm going to just click next. Then we have a few more details here, which really are not very important for our purposes. We can leave them as is. We're not going to use them anyway, except for the apartment stuff, which just means that our component is single threaded, which is required basically when working with Explorer. Anyway, that's going to be good enough. Just click finish. So basically we did nothing here. Okay, we got a few files because of that wizard. In fact, I've also switched to a Visual Studio running within the virtual machine to make it easier for me to test whatever we develop here. So what we get here are a few things that are of interest. We get some stuff here in a new header file called bitness icon handler. We have here the trying to implement this interface that was created for us, but we actually don't need it at all because we're going to implement an existing interface or interfaces. There's no need to actually implement some new interface. I'm going to also remove some junk stuff here, which is mostly there for historical reasons, and we can move on to what we actually need to implement. So this is a class which is a COM class. There is some representation here in the IDL file, which provides all the declarations that are going to be part of a type library generated when compiling this IDL file. Again, if this all sounds completely alien to you, you should probably look at a COM programming class, or at least look at some information, other information online. Maybe I'll do a video about that at some other time. So here we have a call class which we're going to register with this GUID that was generated for us, some random GUID that we need in order for Explorer to identify our component in a unique way. We'll get to that registration a bit later. We have some interface here that was generated for us, but it's completely useless. We don't really need it. We can remove it or not. It doesn't really matter. It's not going to be implemented by our component. So back to our header file. Here's the header file. We have the class, we have some ATL support stuff. This one is about implementing IronNown, and this one is for registering a default class factory. All these things we don't need to really know about. We just need to implement our interfaces. And there are two interfaces to implement. One of them is called extract icon, and the other one is called iPersist file. So this, of course, is all documented in the Windows shell documentation. You notice that extract icon doesn't seem to be recognized here, and that's because it requires an additional include. It's called shell obj core.h. It, of course, is documented as well. So once we have these interfaces, they're just functions which are not implemented. We have to implement it. These are pure virtual functions. We can try to use control to have these things implemented for us. Using iPersist file here, so we can see that Visual Studio is nice enough to generate these empty implementations. And then we'll do the same with iExtractIcon, pressing Control dot and then implement the pure virtual functions there. And we get that implementation here as well. So it saves us time, and we have all these functions declared here and implemented in the CPP file. We can just perhaps improve formatting here a little bit, but not very important here. So what do we actually have to do? Do we have to implement all these functions? Fortunately, the answer is no. We just need to implement some of these functions as defined by the documentation. The first function to implement is called load from the iPersist file, and this is where we get the actual file name that we want to process. This is where we need to figure out what is the bitness of this file, whether it's a 32 or 64-bit bitness. And so for that, we're going to declare a little enumeration here. Let's call that module bitness and give it something like unknown, as something that we don't know what it is about, or maybe the DLL file is not truly a DLL, maybe it just has this extension, but it's not something that we can actually do something with, so it might generate some kind of error. Then we can do something like bit32 and bit64, just have a few values to represent the bitness of a file, and then we'll add a member here to hold on to that module bitness. So we'll just generate one of these variables, let's call that bitness, and I'm going to initialize that to module bitness unknown. I'm going to start with unknown and see if we can figure it out based on the path that we get. Of course, all this stuff probably should be under private, all these things, I'm not going to bother with them too much to focus on the task at hand. So going back here to load, here's where we need to do the actual work. So we need to find out what is the bitness of the file presented to us, if indeed it's something we can do. So the first step is going to be to load the DLL into memory. So let's go ahead and do that by calling the function load library ex. I'm using the library ex because I don't want to load the DLL as a true PE. I don't want it to be mapped or anything like that fully with all the stuff there, imports being read and all these things. I don't need all that. And in fact, if I would load a 32-bit DLL in a 64-bit process, which is how Explorer runs, which will later will load my component, it's not going to work out. So instead, I'm going to use load library ex, and it would allow me some customizations. So first we have the file name here, just pass it along. Then there's a handle which is actually not used in the API, and then there are some flags. And this is where the important thing here is to use load library as data file. We want to use the library as data file, so map it just like data. We could do that differently by using section objects or memory mapped files, but this is just simpler, it's just single call instead of having multiple calls. If this doesn't work, then obviously something is wrong. It means that the file is defective in some way. So I'm going to return as false here, which is a way to say that something went wrong. But in fact, we can even return as okay here regardless, just saying that it's just that the bitness remains. So the bitness of unknown, which is the default, is going to just remain as it is because we can't figure out what the bitness here happens to be. Now, if DLL has been loaded successfully, we can move to the next stage, which is to look at its header, and based on information in the header, we'll be able to figure out whether it's 32 or 64-bit. So I'm going to go with the header by calling the function image anti-header. This is a function that we can use. It's provided by the debug help DLL. And so we can use that. So I need to just pass HDLL here. It's just a pointer technically. And so let's go ahead and add a dbg help here. And now image anti-header is properly recognized. One other thing we have to do technically is that when this is loaded as a data file, the actual value of the pointer has an additional bit of 1 at the end. So we need to remove that bit. I'm going to just use AND1 here to try to remove that bit. Of course, that's not going to work out very nicely because I'll have to do some casting here. So I'm going to do that in a separate line for clarity. So let's just do that. Let's go ahead and make this long pointer, just a normal unsigned long. and then we be able to remove the first bit, and then we can cast it back to a p void, which is really, or to a h module, which is good enough. So here's what we're going to do, something like this. It's a lot of casting, but should be fine. And now we can load the header. If it doesn't work, of course, there's nothing to do, but it should work. There's no good reason for that to actually fail at this point, but let's just check it. So if it is correct, we can go ahead and find the header signature. So our bitness is going to be based on the header signature. So if the header here, the signature is going to be the 64-bit signature, image nt optional HDR 64 magic something like this, then it's going to be module bitness bits 64, otherwise going to be module bitness 32. And we're done. The only thing left to do is to free the DLL properly, so it can be unloaded from memory. There's no need to keep it here, and just return SOK, which means everything is fine. The work has been done. Okay, great. What would be the next step? So one thing we want to use, of course, are two separate icons that we want to utilize. So before we go any further, we want to add these icons as resources. So I've already retrieved the two icons from somewhere. I'm going to go to my project directory here and go to the rest directory. There should be a rest directory here. And if not, we'll just go ahead and make sure that we can add these icons. I'm going to just add them here. That's fine. Here are these two icons. One has the number 64, the other one 32. So this will work just fine for us. And I want to add them as resources into the project. So first thing, we need to see the resources view. We don't see that by default. We can go to view and then other windows and look for the resource view. Here it goes. So I'm going to show here the resources that we have. Currently, we don't have any icons. Let's go ahead and use add resource here and then import. It will allow us to import icons or any other bitmap for that matter, but I actually want icons. So we should have these two icons here. Here it goes. I'm going to select both of them and import them into the project. So now we have these icons. I'm going to give them proper names. So this one is going to be called IDI 32. IDI is short for ID for an icon, so it's just a customary something to use. You can use any name that you want. Just create some constants behind the scenes that we might need to use, so that's fine. We have these icons in our binary, going to be resources, going to be binded with our PE. And then we need to continue implementing the interfaces. So once we've implemented this interface, what would be the next thing we need to implement? And so again, fortunately, there's not a lot of things to implement, but there are a few. So one of them is load, obviously, but then there's another one, which is where we specify the actual icon, and this would be the function get icon location. There's actually more than one way of doing that, but that's going to be good enough for our purposes. So here, what we're supposed to do, we need to get the icon file here returned into this pointer and the index of the icon in case we have more than one icon in a particular file. In the file, of course, is our own file right here. I don't want to have the icons as separate files. I'd like them to be a part of my DLL so I can distribute just a single DLL to my customers that might want to use the same icon handler on their system. So the first thing we need to do is to get the path to our own DLL. So for that, I'm going to need some path. Let's go ahead and create a variable here. I'm going to make it static because it's always the same DLL on a particular system right now. So I just need once to get the value there. So if path 0 is 0, means I've never done this before. So let's go ahead and do that by getting the module handle of our own module. We can use get module file name here. And for that, we need the H instance, the H module of the current DLL, of this DLL. So since we don't write DLL main ourselves, ATL does that. We need to get that information from ATL. And we can do that. There's a p module, which is a global variable provided by ATL, and there's a get module instance there that retrieves that instance. And then the file name is going to be the result, and the size is the number of characters we have there to fill the buffer. So it's going to be a count of path, which just retrieves the number of characters there. And basically we're done. If this doesn't work, things are really bad, but I'm not going to bother checking that, at least not too much. And we're going to stick with that. So, well, let's just do a check anyway. If path here is still 0, it means something went wrong. There's nothing for us to do. We're going to return as false. This is required to say that we have nothing special to say about this file. So the usual, the normal, the default behavior should commence, which means using the registered icon for this kind of file type. If we do have this module properly provided to us, then obviously we can move forward and look at the bitness. So if the bitness here happens to be bitness unknown, it means again we have a failure but of a different kind. We can't identify the bitness of the DLL, so again nothing that we can do about it. We can just bail out and say to Explorer, please use the default behavior. Once we get to this point, we have something that we know is definitely right, and so we first need to copy the file to the file path to PSZ icon file here. So we can use WCS copy S here, which is the function, the safe copy function. We need to copy to icon file. The maximum number we can of characters to copy is CCH max. This is provided as a parameter here, and the actual path is path. So just going to do that to copy the file path. Of course, we hope that the buffer in the colors location, whatever Explorer is providing, is big enough, and I expect that to be at least max path characters, so should be fine. And then we need to provide the index. So the index, since we have two icons in our resources, we need to select the correct one based on the bitness. So if the module bitness is bits 32, then we're going to specify 0, otherwise 1. Why is that correct? Well, actually, I'm not sure. We can go to the Solution Explorer and look for the resource.h file, and this should show us the headers that have been defined for us, where icon IDI 32 is 201, this one's 202, so I expect this to be the first one. Of course, if it's not right, once we start testing, we can change that later on. So we'll stick with these indices, and then we can say finally as OK. There's one more thing we have to do here. There's a bunch of flags here, and these flags, we have to specify the flag called per instance. This is important because we want to tell Explorer that this thing should be called for every DLL, for every separate file. It's not just calling this once, getting some custom icon from somewhere. We want to have different icons potentially for different files. So this says to Explorer, or whoever is calling that, this is a per instance kind of thing. It's not a per class, like something which is just global. And that should be good enough to implement this function. What else do we need to do here? We've implemented load and we've implemented get icon location. I think this is actually all we need to do. At least that's is my hope. Let's see. So first, let's try to build it, see what's going on. Maybe it doesn't even build, who knows? So things are being compiled. I expect things to compile, but probably not to link. Well, actually they will link, but they will fail registration. And well, actually they fail linking. And that's because debug help, we also need to have an import library here. And that one is called dbg help. So let's just add that lib file. I'm going to use the pragma here to make it easier instead of going to the project properties. And now we can see things work in the sense that the DLL has been built, but registration here failed. And registration is really about writing certain stuff into the registry in order to register our COM component based on its class ID, the one that we see here in the IDL file, that would be the class ID. And by default, the script that is accompanying this ATL project tries to write it into HKey local machine. That causes a failure, because for that to work, we have to restart our Visual Studio and work with an administrative access here. That's one way of going about it. Another way of going about it is to go to the properties of the project. Let's go ahead and select all platforms and all configurations, and select in the linker, let's look for the ability to write something which is on a per user basis. This will make it write the registration into HKey current user, which is also something that's supported in COM, which does not require an admin access. So let's do that. And now it's supposed to have registered the DLL successfully, hopefully. And if not, we'll register that again very soon. Speaking of registration, what do we actually have to do here? Now, if we open a registry editor, let's use the standard Windows registry editor here. How does Explorer know which icon to show for DLL file? So here's what that looks like. There's HKey classes root, which is the one that Explorer uses, which is actually a combination of two hives coming from HKey local machine software classes and HKey current user software classes. And here, if you look for something like DLL file, this is where it's going to provide information about DLL extensions. Technically, you can start by .dll. With .dll, you'll find the default value here saying DLL file. So you have to go to DLL file. And with DLL file, you'll find there's a default icon. This is the default icon provided by Windows, like by default. And you can see here the syntax looks kind of weird. It just says that image_res.dll is where the icon is, and 67 is the index of the icon within the DLL. And so that's going to be the default, and that's what we have seen here when looking at CCM32. That's the icon here. I can prove that by extracting icons from this DLL, but we won't do that in this video. Anyway, by looking at shell here, there's stuff we can add in order to customize the icon of DLL files based on the class that we have provided. For that, we need to provide proper registration. So fortunately, ATL helps with that by allowing us to write very simple registration scripts. And so now we have a single registration script that has some meaning. That's not the one, that's the one that has no meaning. Here's the one that has some meaning. This represents the actual component. Notice the class ID is right here. And it actually registers this as a normal COM component, just like any other. And again, if this looks alien to you, it's perfectly understandable. But again, I recommend you look for resources online, or take my COM programming class and understand exactly what that all these things mean. But for Explorer shell extensions, we have to do some extra registration, so Explorer knows that we're actually providing some custom component for icon handler, for an icon handler. And same goes for other kinds of shell extensions. So I'm going to add that here into a kind of a global stuff where we can specify things. And if you go to the registry, we've seen that there's a DLL file here. So DLL file is the key I'm after. That's DLL file right here under HKey classes root, which is what HKCR means here. No remove just means that whenever this DLL is unregistered, don't kill all the DLL file key here, but just remove that particular entry. And then within it, we have to use no remove again, and use something called shell X. So here, going back, you can see there's shell, but in fact there's shell X you can add for custom stuff. And again, all the stuff I'm showing here is fully documented, just need to know what to write. Here we have to specify the icon handler. We need to specify as a string the GUID of the component, which means we have to go either to the IDL or the other RGS file registration script and just paste in the string here, like so. And now if we build this, hopefully, it will now build successfully and also register that. Let's see. If it doesn't, we can run it externally. So let's go F5. Notice shell X has been added here, icon handler has been added. Here's our class ID, just to prove that it properly is registered. We can copy that class ID and go to the normal location where COM uses for registration called CLSID. I'm going to open that up under HKey class/root, use find, and paste the key. We should find it, and you can see that it indeed is here, and inproc server 32 should point to exactly where our output DLL is. So it's right here where we expect it to be. So that's exactly what we were hoping for, and all registration seems to be just fine. So now we want to test this. So if I go to my Explorer, let's see if it works. So here's the system32. Let me press F5. Does that work? Doesn't seem to work very well. Let's go ahead and add another, maybe another C Windows 32 or something. See if we try this again, maybe it will have a better kind of effect. So let's go with system32 where there are many DLLs. And we don't seem to see that working. And the reason might be because Explorer by default doesn't really know that I've added this entry in the registry, so it doesn't know to look for my DLL, probably. We can verify that by opening some tools such as the Process Explorer. So let's go ahead and open Process Explorer. We can look for our DLL. Let's see if it's actually in Explorer somewhere. If it is, then obviously something is wrong, or perhaps something is wrong, but if not, then maybe there's something else we need to do. So here's Explorer. There are in fact two Explorer processes here. Let's look at the DLLs, and our DLL is called DLL icon handler. As it happens, it's not here. Let's go here. DLL icon handler doesn't seem to be here either. You can of course just do Ctrl+Shift+F and look for that. We expect that to exist in Explorer if everything works as planned, but probably won't find it right now. And again, the reason is because Explorer has no way to track these things. Doesn't really know that things have changed in the registry. It would be too expensive for it to monitor all the possible keys. So we'll have to force it by just killing Explorer and launching it again. So let's go ahead and do that. So let's just kill Explorer here. Let's kill the other one as well. I'm not sure which one we should kill. We'll just kill both of them. Now we have no Explorers. Let's just go ahead and run a new Explorer here and hope for the best. So here goes. Explorer comes up. The taskbar comes into play. Now we can see what is going on even before opening any actual file. Let's see if our DLL has been loaded. Okay, let's see. So apparently nothing has been loaded yet. Well, another test here. Let's go with system32. Something did happen. So something did happen, something went wrong, and we got some weird error here. And that's, well, that's fine, I guess. It's something that we perhaps weren't prepared for. So something went wrong. Okay, fine. Let's go back to my code and see what went wrong. Now, one of the problems when writing these kinds of handlers, because Explorer is the one that is loading them, it's not very easy to debug. Because once you set a breakpoint inside Explorer, then bad things might happen, because once you're in a breakpoint, Explorer is actually not moving anywhere. So now if you try to do various operations that Explorer also is involved in, they will just freeze up everything. That's of course not going to be something that is easy to deal with. And so we have to find a different way to debug perhaps. And the one way would be to add various traces into the code and hoping to find exactly the place where things went wrong. And one thing I forgot completely is to add interfaces to the COM map, indicating which interface we're actually implementing. That was kind of silly of me. So let's go ahead and use COM interface entry here to add these interfaces. That would be RPS persist file. And I extract icon. The reason for that is that the implementation of IUnknown is based on this map. If you don't provide this information, there's no way this could actually work. And so Explorer probably tried to query for one of these interfaces, and this didn't really work. Even before that, ATL was providing a warning with that assert saying that the map was basically empty. So now we can try this again. Let's go ahead and try System32 again, see what happens now. Okay, so at least we didn't get any kind of crash, but the DLLs don't show any one of our nice icons, even though at the very least we don't see that default icon. Let's look at Explorer here, see if anything has changed here in Explorer. So let's open that up. This Explorer specifically note here that our DLL is in the process. So something is working, but not exactly as we were hoping. We might need to check our information in terms of maybe we have some bug there somewhere. Again, it's not going to be very easy to do, but we can try perhaps to add some traces to the code. Okay, let's add some trace here. Let's see what we get when we calculate the bitness of a file, just to see that we're on the right track, so to speak. So if we have a header here, let's go ahead and add a trace here. I'm going to use the ATL trace macro and say that bitness of file, and we'll provide the file name, is %d, and we use the simple value of the enum. It should be either 1 or 2. So we have the file name, psz file name, and the value itself, which is bitness. I'm just going to display that, and where we're going to see that actually. So first, notice that when I try to compile that, it won't properly link because it's being taken by Explorer now, and it's not going to be released by Explorer. So let's just go ahead and we'll have to forcefully ask this Explorer instance to relinquish control of the DLL so we can properly build it. Let's build it. So now it builds successfully until the next time it is needed. And before we do that, we're going to use a tool called debug view from sysinternals to see these outputs without having to get any kind of debugger here. Let's just go ahead and ask for everything. So let me just make sure we have capturing of Win32. We don't want to capture any kernel kind of stuff. That should be good enough. And let's go ahead and try this again. To try this again, we can just, since we have rebuilt, we just need to run another System32 or some other directory where this handler will have to be loaded by Explorer. Explorer will be forced to load that. So once we do that, we should see some items here happening. And so things are definitely weird here because dbg view has crashed. So let me try one of my own tools called debug print. Hopefully it will behave nicer, we'll see. We don't want to actually see kernel stuff, we just want to see user mode stuff. So that should be fine. Okay, let's clear this and try this again. So if I do refresh, I'm not sure that's going to be good enough. Yes, good enough. We can see various outputs here. So obviously there is some bitness here, let's see. We get 1, which is supposed to be, 64, 32, one of them. So obviously something here is working fine. We have the correct bitness. Everything seems to be fine from that perspective, which means that the problem is probably elsewhere. Maybe in a way we provide the icons there, perhaps. So we'll need to do some other test there. Again, going back here, let me do some changes here. We can leave this if we want to, and then let's go to get icon location here. Let's make sure we have everything we need here. We get to this location. Maybe I have a bug even before getting to to that particular piece of code. So maybe we're not even getting to this location at all. So let's again add a trace here saying that icon index for file, and the file is going to be that particular one that we have here. So we'll have here a psz icon file. That's the one that we should be looking at. That's the thing we copied right here, which is supposed to be the path to our module, which means our own DLL. And then the index itself, which is going to be pi index. So again, going to compile that, it won't work. We have to kill Explorer again. It's holding on to our DLL. Let's go do that. Notice that all Explorer windows have been destroyed. And now we're doing the same thing. Here's debug print. Let's go ahead and clear everything and run system32, see if we get something useful from the output. Okay, so we get output, and we have this DLL and the icon index. Let's see. So icon index is 0 in this case, which is fine. I mean, this should provide some kind of icon. Maybe it's the wrong one. Maybe we need to switch that to the other icon based on the actual order within the resources, but at least we should be able to see something, but we see nothing, which is very weird. Okay, there's not a little detail I forgot to implement apparently. Now remember, this extract function has to return as false, otherwise it is the one that's going to be potentially used for extraction. And again, we landed in the same problem. Let's do that one more time. This video turns to be much longer than I anticipated, but that's part of the fun, I guess. Okay, let's try it one more time. Okay, so system32. Now something works, but it is the wrong one. Well, we can just switch that. Let's make sure. Let's go to syswow64, making sure that it actually provides the correct icon, at least in reverse. So let's go to all these DLLs. So apparently something is wrong here. It's always identifying things as 32-bit, which means that my code is not good. So we'll have to actually change the code here. I was kind of optimistic, hoping that this magic thing will do the work and I don't need to do anything else about that. But unfortunately, I was, well, too optimistic. So the signature of the header, unfortunately, is not good enough. Apparently, that's just the fact of life, I guess. I was hoping that this would be a 64-bit thing and that would be enough. But apparently it's not good enough. So in order to make sure that it is in fact something that is 64-bit, we're also going to compare the machine. And so the machine type, that is the CPU type, is under the header with file header.machine. So I'm going to grab this machine and try to use that as a way to decide. So if that's something that we have, that might not be good enough. Let's make sure that the machine is image file machine. And there are a few constants here, what we want to use is what we have here on Windows, which is either AMD 64, that's the 64-bit CPUs from Intel or AMD, and we also have the ARM 64, so the same thing, just with ARM 64. If this is one of those, then this is a 64-bit PE, otherwise it's going to be a 32-bit PE. I think that should work better. Let's give it a shot. Again, we might need to remove that, but here you can see Explorer is actually smarter. Once we closed all the Explorer windows, it actually unloaded our DLL. That's very nice. That's very kind of Explorer here. So now let's go ahead and try this one more time. It doesn't mean that it's always going to work like that, but it's nice that it has been maybe improved in that way. So here's 64, exactly what as we expect. Let's go to syswow 32, syswow 64. If I can do that correctly, of course. Syswow 64. Here goes. DLLs here. Oh, 64-bit as well. That's disappointing, definitely. And that's because I have another bug here. That's having machine equals, of course, and not just using that in this way. Let's try this trick again. Let's kill the Explorer window, see if it releases the DLL. Maybe it has some kind of timer for that, so I can't do it right now. Let's just kill that Explorer. I hope that's the right one. Okay, let's try it again. Final time. Not yet. Need to build the DLL first. Okay, here goes. 64-bit, okay, that's no big surprise there. Syswow 64, 32, finally works. So there you have it. That's an icon handler. Of course, you can do anything you want with any kind of file that you want in any kind of way that makes sense for what you're trying to do. It's just an example, of course. You can see these things in any directory. Of course, it has nothing to do with System32 or syswow64. If we go to something like where our code resides, you'll notice that the DLL itself that we have written actually has this appropriate icon now. It's just one of those icons that I just use here for all DLLs. That's going to be 64. It's going to show 64 here. If I recompile my code to 32, that would be useful for a 32-bit Windows if you can find something like this, then we expect the resulting DLL to have that other icon for x86 for 32-bit. So here goes. Now it has this particular icon. So there you have it. So this video has been a bit long, much longer than I anticipated, but that's some of the fun, debugging things live. So hopefully this makes sense. Feel free to try it out yourself and see what you get. I just realized where my bug was when testing for bitness. So in fact, this check is correct, but not the right field. So I don't really need the actual machine. I just need to go to header and then optional header. And this is where the magic number is. So that was a bug that really should be fixed to make the code, well, a little bit more correct. So just go ahead and do that for correctness.